Hey guys, this is Professor Janacek. I want to go over another example of evaluating a surface integral on a scalar valued function. So we want to find the area of the hemisphere x squared plus y squared plus z squared is equal to 100 for z greater than or equal to 0. And we're going to use a parametric description for this. So using parametric description, we're going to, of course, rewrite our function in terms of the parameters u and v, and then we'll use this double integral here to set up, to evaluate that. Okay, so let's see. First off, our surface is x squared plus y squared plus z squared equals to 100, which I'm going to go ahead and write as 10 squared, so that I can make it a little easier to write it out parametrically. This parametric description we'll call R. Remember, R is a function of u and v, so my x, my y, and my z, I need to rewrite all of those in terms of u's and v's. So this would be what? 10. This is a hemisphere. So a sphere, remember, is 10 sine u cosine v, 10 sine u sine v, and let's see, the last one is just 10 cosine u. And let's see, some things to make note of with this, that u, if you recall, goes from 0 to 2 pi. Oh, wait. Hold on, we're looking at a hemisphere here. Okay, so just be aware, make sure you're comfortable with this. This shape here has the look, let's see, it's the hemisphere where z is greater than or equal to 0, so it's something like this. This is our shape. U goes from, let's see, U goes this way, and V will go that way. All right, so that means U goes from, in this case, actually I even drew that too far. U goes I just need to go to the top. And so U is between 0 and pi over 2. It's just that top half. And then V goes all the way around, so that's from 0 to 2 pi. All right, and then also we're going to need the magnitude of that cross product. And just to make it easier, we'll just write that down, computing it. You might have some of these memorized, but you can also compute it if necessary. In this situation, the magnitude of TU crossed with, goodness, what am I doing? If I could get this to, there we go. The magnitude of TU crossed with TV is, let's see, that ends up being 100 sine u. Oh, is that right? Yeah, a squared, yep, there it is. Okay, so let's go ahead and set up this integral. Oh, we need to know what f is. Oh, that's another thing. So in this case, look at what we're doing. We're trying to find an area. Oh, that's a surface area. Ah, well, if we're looking for surface area, then for the surface integral, we're going to have to let f equal to 1. So our function here, f, is simply equal to 1. So now let's go ahead and set up that surface integral of 1 ds. That is the double integral. Let's see, we'll do u on the outside. So u goes from 0 to pi over 2. And v goes from 0 to 2 pi. So our integrand, of course, remember, is f times that magnitude of the cross product. So that is 1 times 100 sine u. And we will integrate this with respect to v and then with respect to u. So what does that give us? Well, I'll go ahead and factor out that 100. If my pen will work. There we go. And then integrate u, sine of u, with respect to v first. That gives us 100 times the integral from 0 to pi over 2 of v sine u evaluated from 0 to 2 pi which gives us 100 times the integral from 0 to 2 pi of evaluating v equal to 2 pi and then v equal to 0. The integrand then becomes the integrand is 2 pi sine of u. There should be a du. Ah, this pen. Oh my goodness. Make sure you recognize what that is. Okay, and let's see, I can factor out the 2 pi, so we get 200 pi times the integral 0 to pi over 2 of sine u du which is 200 pi times negative cosine u evaluated from 0 to pi over 2. Which is 200 pi times negative cosine of pi over 2 cosine of pi over 2 is 0 minus a negative cosine of 0, which is 1. So that ends up being just 200 pi. And there we go. Enjoy!